Okay, hello chemistry students. My name is Mr. Hood, and obviously I'm filming this on National Mole Day. It's October 23rd, so it's not published yet, but I'm starting to film this on October 23rd because today is 10/23. It's National Mole Day. 6.02 times 10 to the 23rd is Avogadro's number, and 1 mole of any substance has that many particles. It could be 1 mole of atoms, 1 mole of ionic compound, 1 mole of covalent compound, and it could be a mole of cars or a mole of people. 23rd. So today in this lab, I'm going to give my students a sample of copper 2 sulfate, cupric sulfate, and it does have a formula CuSO4, but this is not pure CuSO4. It's in the hydrated form. So in the CuSO4, there's an unknown number of waters. Now you can Google it and find it rather quickly, but my students have to mathematically find how many waters per formula unit in CuSO4. So how are we going to do this? Okay, here's the setup. I'm going to find about 5 grams of this, roughly 5 grams. Why more? Why not more? It would take longer to heat up. So we're going to heat this up with a different kind of burner. And historically, the burners, when I got this job, the ones I inherited were these type called a Meeker burner. It's a lot of flame here. It's a high temperature flame, so it works very well. We'll keep it on low heat though, low amount of gas. This is a regular no adjustment Bunsen burner. All you can do is adjust the amount of oxygen coming in, and this has a gas valve. And I think I've seen this one called a Bunsen, this one called a Tyrrell, and this one called a Meeker burner. And I'm sure there's different names for different burners. That's the 3 we had in our lab. We don't use these because I only have one of them for historical reasons. We use mostly these and then sometimes these. And I'll just use this one today just to show you how it works. So I'm going to add roughly 5 grams of this salt into this evaporating dish. And my camera person will help me later when I finish this lab. But I'm about to go get 5 grams of this salt in a moment. Hello there. I'm about to add 5 grams of this salt in this evaporating dish. And this was kind of an interesting thing. Some of you in different labs may have purchased this brand. So I'm not going to head for the mountains, but I think it is made in Colorado. So Coors, I think the Coors Corporation does more than make beer. So I'm going to put that in there. I'm going to tear it, bring it back to 0. Then I'll add roughly 5 grams. That's a little bit much, 6.526. I'm just going to remove that much. Now, am I going to pour it back in this bottle? No, I'm not going to. I'm going to have a little waste dish over here. And I could have 5, 6, 10. That's 5.660 grams. 5.660 grams. Now I'm going to heat it up here. I'll start the burner in a moment, but class is about to begin. I won't have time to finish this lab, so I'll pause it later, but I will show you how to light this burner. Now, it's probably better to not have this going on and get hot a long time. This is very hot, so I'm going to use a ring stand, and I use sometimes a clay triangle or wire gauze to hold it carefully. And as I heat this up, I'll use my dish tongs to hold it while I stir with my scoop or scoopula. And it's like I'm stir frying. Every time I do this lab, I think of stir fry because you're going to hear the sizzle as the water molecules leave the hydrated copper 2 sulfate. But I'm going to show you how to use a striker. Those who work in cutting torches and welding sometimes uses a striker to begin. So I'm going to turn this on and you can hear it. Hear that? And I'll use a low flame for a few minutes. Don't want to burn myself. And I'll be stirring it. The moment you start to heat it, the water is it's weird because you're drying it out, but it gets sticky for a while and clumpy, and I'm gonna get rid of the clumps. And we'll continue this lab later. Okay, earlier today we took the mass, and now it's been sitting here. I'm gonna restart this. Now it's after school, and we can finally video this. Remember how to start a burner. You turn the gas on till you hear it, and the striker works. I'm gonna turn this flame on a little bit low, because this is gonna get hot. You can feel the heat. So as this, if you can zoom in, as this starts to heat, you're going to see this clump up into chunks, and you're going to crush the chunks, try to get every single water molecule that we can out of this crystalline structure. And it's actually backwards. You think, well, I'm heating it off, so it's getting clumpy as I heat it off because the water's leaving the crystal and getting humidity. And you can see as you heat it, the blue color is going to get lighter, and it's going to be kind of a grayish powder when we're done. That's when I'll know when I'm done heating it off. So see how it's kind of, do you hear the sizzle?
Mm-hmm. I hear it.
Yes. Snap, crackle, pop, Rice Krispies. That's back in the day. I don't think they have that commercial anymore. All right. Well, camera person, come back in about 10 minutes, okay?
All right.
Thank you. Then we'll see the white powder. Okay, this is just an intermediate video. See that white powder in there?
Mm-hmm.
The water's being driven off, and it's still sizzling. In about, oh, it's hot. In several minutes. Turn it a little bit lower flame. There we go. In a few minutes, the sizzling will be gone. The blue will be gone. But you can see that whitish powder, and it'll be all white powder in about 5 or 10 minutes. Okay. So.
Well, I see down at the bottom where the wire has chipped loose, or the ceramic has chipped loose from the wire. The wire is glowing orange.
Yeah, these gauzes are about, I've been in this job 16 years, so about 20, 30 years. So it's like glory. It lasts forever.
Yeah.
Now, I think we did buy some new materials the other day. Turn that on low. I turn that on low, and I'll take a little break from filming the white powder. Over here, we just did a redox titration with iron 2, and this was the unknown. And it also is a hydrated form, and I can do the spoiler alert now. It's 7 H2Os. If you look in there, there's the 7 H2O. It's a heptahydrate. And you can Google what the copper 2 sulfate is, but I want my students to mathematically prove it. So we'll see in a few minutes. Used to look like this, now turned into this kind of light gray powder. And if you cooked it a little bit too high flame, you got kind of brown. I'm not sure if that affects the results or not, but in a few minutes, I can use this glove to bring it back to the balance. Bring balance back to the 4, so bring the dish back to the balance. So we'll find that mass in a little bit. Why is it negative 50.044? Because I had the dish on there, and I pressed tare, T-A-R-E, kind of like the parable of the tares. It's the stuff that's left over. So when you tear something, you subtract it. So I'll let that cool for a while, then find the mass again.
Okay.
Okay, it's been about 10 minutes since we did this earlier, but if it was still warm, you could use this asbestos glove or insulating glove, I don't know if it's asbestos, and carry it over to the balance. But right now, it is already cool, so I can actually hold it with my hand. It's still warm, but it's enough to touch. So I'm going to find this mass again. It's going to be less than 5 grams. So it was 5.660. Now it is 3.691. So almost 2 grams have gone. And I will, so say that number again. It was 3.693 grams. Okay,
It just changed.
I'll write that. And of course it changes a little bit.
It's 3.692 right now.
Okay, good. I'll write that down and I'll put that data on the video later. But you'll see it doesn't read. It fluctuates the thousandth of a gram. This is a milligram balance. Very nice balance. So this is the cool powder now. It's dehydrated. If I let this sit out in Houston, then it would turn back blue. But here in Canadian, where the humidity is very low still, and it's October 23rd, National Mole Day, it wouldn't be. I've got the mass of this. Now it's not important. So I'm gonna take a look at this. And over here, my students in real life will get to feel what's happening under this watch glass. But as I add a little bit of water to it, of course, when I heat it up, the water is released. When I add water, we'll see what happens. Listen.
Cool.
And that sizzle, then you can imagine that I'm feeling a little bit of warmth underneath here, and it rehydrated to turn blue. So people ask me, well, why do they send it blue? Because it takes heat to drive it off. It's easier to ship a little bit heavier mass of crystal than it is to heat it up, keep it dehydrated, and it's not important. And I was trying to think of several uses for this copper 2 sulfate. One of the things I saw earlier, they put it in solution and pour it down drains to kill tree roots. So the copper 2 sulfate, like normal salt, will kill plants. So this is a kind of salt that will kill tree roots in plumbing. And it's copper, so it wouldn't replace the copper pipe. But I think most pipe now is PVC plastic, which has a little bit more flex and it has a little bit less chemical resistance. So, I mean more chemical resistance. So this was a lab of copper 2 sulfate finding the missing number in the hydration number, and I'll post this data at the end of the video and we'll be able to work it out. I was trying to think if there's anything else I was talking about. We talked about the mass. I showed you rehydrating, and you could imagine that it feels warm. So adding heat to drive off the water was endothermic. This is the reverse. So when you added water to drive off the water, it was endo. When water was added, it was exothermic. So you could feel the heat, and we'll be talking more about heat of solution later. So, okay, thank you for the video.
All right.